course Spring 2021. In lecture number 15, we were discussing about the phase analysis of a system, and we define a group delay quantity. And we said that if the phase response of a system is linear, then we have no phase distortion, and this is the ideal situation for me. And all FIR systems, they have a linear phase response, and a linear phase response means that their group delay must be a constant, right? So if let's consider that theta of omega, theta as a function of omega, is a linear function over the frequency, then we can define group delay as a function of frequency as well, and it is equal to the negative of the derivative of the phase response of a system, right? So we can also define group delay as a group delay is the measure of phase distortion of a system, of the system, right? So it's a measure of the phase distortion of a system. So if the group delay is a constant function, then we are okay. But if the group delay is not a constant function of frequency, then we might have some problem. So we need to be careful while defining the group delay quantity, right? So we defined that uh, all FIR system, they have a constant group delay, uh, linear phase response, or constant group delay. And an IR system, it may be linear, it may not be the linear case. So that's an issue. So for IIR system, we need a rigorous phase analysis in order to study the phase distortion of those systems, right? So for FIR system, our life is easy, but for IR system, our life is little bit tough. We have to perform the linear analysis. Let me share a graph with you. If we have a phase response, we said that if we have, this is theta of omega versus omega, and let's consider we take increasing pattern with blue color, like this, or this, and we select sorry, red color for decreasing linear patterns, like this. So um, if we take the group delay, GD stand for group delay, then the group delay function would behave like this, like this. If this is omega versus GD group delay as a function of frequency, then we can see that these red lines can be represented as a constant function in the positive axis of y, and your blue lines are represented because they are increasing, but when you plot a group delay, it's a negative of the derivative of the phase response of a system. So positive would become negative. So here you can visualize the group delay of a linear. So you can measure phase distortion in terms of a phase, and you can measure the phase distortion in terms of a group delay as well, because you can see that linear phase system will have a constant group delay response, right? So there is a constant value across all frequencies. So 1 kilohertz, 2 kilohertz, 3 kilohertz, 10 kilohertz, 1 megahertz, 1 gigahertz. For all frequencies, group delay response would be a constant value. So you can define phase distortion. Let me write here explicitly. You can define phase distortion either in terms of phase or group delay. So you have both options. So, but if we see these two graphs, it's easy to understand and easy to define the phase distortion in terms of a group delay, because it's a constant. So we just need to check if the group delay of a system is a constant. We say that we are happy, we have no phase distortion. And if the group delay is not a constant, it means that we have a phase distortion. So let's together define this. If phase group delay response is a constant function of frequency, then it is called it is good thing for us as it is not causing any phase distortion. However, if the phase group delay response is not constant, then it will uh, cause phase distortion. Right? It will cause phase distortion. Let's define this using two examples. Example number one. Now we our concept about group delay and phase response is clear. This is not GE but GD. If GD's response is a constant, we are happy. Let me mark happy sign here. So because our life would become easy, we have no phase distortion and we are much happy, double happy. And if this is a phase distortion, then we are not happy about it. Okay, so let's solve an example together. Okay, let's consider a system. This is time domain, and let's consider this is a frequency domain. So let's consider a signal with three distinct frequencies. Let me define high frequency with green color. Let's consider this is a very high frequency. And this frequency of a signal start from zero and it happens till, let's assume, this is 50th sample. This is starting from zero, time t is equal to zero, and it's running till 50. And then from 50, we can consider a blue one. From 50, you have a low frequency signal, right? So it runs till 100, right? So you have a high, you have a low, and then from 100 to 50, 150, we have some medium frequency. Let's assume we define medium frequency like this. So clearly, let's assume this is 150. So this is some medium frequency. So let's define their frequencies as this is 3 kilohertz, just for clarity. This is 1 kilohertz and this is 2 kilohertz. And let's plot its frequency, take DTFT, discrete Fourier transform. And in frequency domain, we are sure that we have three frequency components. That is, this is x of n. We assume that this is a sampled version. या आपको इस तरह नहीं मिलेंगे बल्कि यहाँ पे सैंपल्स मिलेंगे, सैंपल्स की फॉर्म. We just assume that it is free sample. Then we have three components. Let me define those components one by one. So we have a medium frequency component. This is 2 kilohertz. We have one low frequency that might be at 1 kilohertz, and we have another component, green component. Third one, this might be the 3 kilohertz. So you can call this as high. You can call this as medium, and you can call this as low frequency component. And you call this as 1k hertz. This is 3 kilohertz, and red one is 2 kilohertz. ठीक है बेटा, it's clear. This is your time domain x of n. This is x e to raise per j omega. So you can write this as x e to raise per j omega, and let's mod. So this is the magnitude response of a signal. ठीक है बेटा, clear है? ठीक है बेटा?
Yes, sir, clear.
Yes, sir.
Okay, let's consider our box as h of n. Let's consider a system h of n. एक हमने सिस्टम कंसिडर किया, लेट कंसिडर एज अ ब्लैक बॉक्स. हम अभी नहीं देख रहे कि इसके अंदर क्या है. लेट्स डिफाइन इज एक्स ऑफ एन एंड लेट्स टेक इट्स मैग्नीट्यूड एंड फेज प्लॉट्स, बोथ मैग्नीट्यूड एंड फेज प्लॉट. सो अगर हम एच ऑफ एन का फोरियर ट्रांसफॉर्म लेंगे तो वी विल गेट एच ई टू रेज पर जे ओमेगा. लेट्स डिफाइन टू एंटिटीज, omega versus h e to raise per j omega. Mod mean magnitude response, and we define another. अभी हमें नहीं पता कि h के अंदर क्या है. We are just ignoring it. Just for an understanding perspective, we are plotting its magnitude and phase plot. Let's for simplicity we assume that its magnitude plot. Let me take this color. Its magnitude plot is flat, constant, all pass. So its magnitude is 1. So it's not creating any distortion. It's not amplifying. Neither it is going down less than 1. अगर less than 1 होता तो it would be a distortion. अगर greater than 1 होता तो amplification. ना हम amplification कर रहे हैं ना हम distortion कर रहे हैं. हम कह रहे हैं कि सारी frequencies को pass कर दो. And here omega is, let's assume its phase response is linear. Let me draw it with purple color, and let's take it negative, this one, right? So this is the phase response of the system. So it's linear and it is decreasing, right? So once it is linear and decreasing, what would be the group delay response of this system? Can you plot the group delay response? Anyone can help me to draw its group delay response? क्या आएगा बेटा इसका ग्रुप डिले रिस्पांस? ग्रुप डिले रिस्पांस क्या आना चाहिए? Are you with me? I'm asking to you, इसका ग्रुप डिले रिस्पांस क्या आएगा? No one is here to. We just define it. अभी हम डिफाइन करके आए हैं कि अगर हमारे पास डिक्रीजिंग रेड पैटर्न होगा तो अगर ये 0 में से पास करेगा तो वी हैव अ कांस्टेंट रिस्पांस, ग्रुप डिले रिस्पांस. What's the difficulty in this concept? At least you should reply yes or no. Are you with me? Can you hear me?
Sir, yes, sir, we can hear you, but sir, इसका वो
This is strange response. Anyway, if we have a linear phase system, we have a constant group delay response. So we will have a constant group delay response. So it will have a straight line because linear phase system has constant group delay response. Like, so let's assume this straight line showing m is equal to 30. Right? Let me first define you y is equal to mx plus c. Let me first give you an example. If y is equal to, copy some equation if I already put some equation here. अगर बेटा आपके पास ये हो y is equal to mx plus c, so what would be the y is equal to mx plus c, right? So what would be the value of the derivative?
M.
Derivative is equal to m. Thank you, beta. dy by dx will be equal to dy by dx, d by dx. The answer would be equal to m. Right, so this is general linear phase system, generic, general linear. However, in our case, हमारे केस में क्या होगा? हमारे केस में this is theta of omega because we are on our y-axis. This is theta as a function of omega. Function of omega. Let's we define as m as the slope and omega as x frequency, m dot omega. And let's define slope c as a constant value. If it is, this is intercept. If you are intercepting at 0 axis, its value is 0. So what would be the value of dy by d omega over d theta over d omega? D by d omega. जी बेटा, क्या वैल्यू आ जाएगी? What would be the answer?
So it will still be M.
It still be m. Thank you. So from here we can see that this is a linearly decreasing line. So when you take, because you are in phase, what you are taking negative of the derivative. If you multiplying in negative of the derivative of the phase response of a system, so this is minus m. ऐसे ही है बेटा, because
Yes.
slope,
जी
here
सर
slope is positive, here slope is positive, but अगर हमारे पास slope negative हो तो m would become negative, और negative slope क्या हो जाएगा? For negative slope m, अगर हमारे पास नेगेटिव स्लोप है तो ये m की वैल्यू क्या हो जाएगी? इट वुड बिकम माइनस m, एंड माइनस minus it would be plus m. ऐसे ही है बेटा हमारे केस में क्योंकि माइनस आ रही है तो दिस इज इक्वल टू m.
Yes, sir.
ठीक है बेटा. एंड अगर आप इस सिर्फ इस क्वांटिटी को डिफाइन करें नेगेटिव ऑफ द डेरिवेटिव ऑफ द फेज रिस्पांस, मैं बाकी सारी चीजें डिलीट कर देता हूँ यहाँ से. तो अगर आप नेगेटिव ऑफ द डेरिवेटिव ऑफ द फेज रिस्पांस ऑफ अ सिस्टम सो यू डिफाइन इट ग्रुप डिले. ऐसे ही है, ऐसे ही है ना बेटा.
Yes, sir.
Yes, sir.
So it's mean, what does it mean? Conclusion is that your group delay is equal to m, which is equal to m. So that why I have done in this equation that if I have a linearly decreasing phase, its group delay will be a constant function which is equal to the slope of the system. ठीक है बेटा. अब m is equal to, what does mean by m is equal to 30? Let's draw the output because we have to pass the signal x through the h and get the output. Let me draw the output response of a system. When I want to draw the output, let me take the same signal from here till here. Since our m is equal to 30, it's mean that now our signal will start from 30, not it's starting from time t is equal to 0. And it is constant, so all frequencies, because low frequency, medium frequency, high frequency, they will get the group delay of m is equal to 30. So mean all frequencies will be shifted 30 samples, right? So let me, first we have a green, then blue, and then the red one. So green. So it's mean that our output response will be like this. So it's a high frequency. It's starting from 30, 30 plus 50. पहले ये 0 पे था, 0 to 50. अब इसमें आप 30 samples add कर देंगे तो it runs from 30 to 80. Right, so it runs from 30 to 80, and then there is a low frequency that is running from 80 to 130. So this could be 130. And lastly, you have a medium frequency that starts from 130 because initially it's starting from 100, but because of this delay, it starts from 130 and approach to 180. Concept clear हुआ है कि क्या effect क्या हो रहा है?
Yes, sir.
Yes, sir.
So you have only delay. So अगर हम input और output को देखें तो I can write expression that y of n is simply equal to x of n only with 30 sample delay. But that only possible when you have a constant group delay function. This is only possible when you have a constant group delay function. Let's take, दोबारा से देखिए मैंने किया क्या है. What I have did, I have used this principle. I have x of n and I pass this x of n into h of n system and I got output response y of n. यहाँ पे हम हॉरिजॉन्टली देख रहे हैं चीज़ों को, जबकि हमने यहाँ पे देखा है इसको वर्टिकली. So what I am doing, I have x of n in which way I have three distinct frequencies, 1 kilohertz, 2 kilohertz, 3 kilohertz, right? So let me draw an arrow which indicates that I am passing this through a system, and after the system I am getting this output response. But this system has magnitude response, this one, phase response, this one, and group delay response, this one. Okay, so let me draw arrows with some different color. Let's say this one. So this is the magnitude response, phase response, and group delay. Group delay, GD response, phase response, and this is magnitude response of this system. क्लियर हुआ है बेटा? ये एक ऐसा सिस्टम है जिसका ये मैग्नीट्यूड
Yes,
रिस्पांस है,
sir.
फेज रिस्पांस है। तो अगर हमारा फेज रिस्पांस लीनियर होता है या ग्रुप डिले कांस्टेंट होता है तो हमारी लाइफ आसान है। सिर्फ हमारी जो फ्रीक्वेंसीज हैं वो सारी सेम ऑर्डर में आगे जा रही हैं, पहले हाई आ रही है, फिर लो आ रही है, फिर मीडियम आ रही है। तो इनपुट में भी पहले हाई फ्रिक्वेंसी आ रही थी, फिर लो आ रही थी, फिर मीडियम आ रही थी। The integrity of your input signal will not be disturbed. It will remain same. It will be preserved. But what will happen अगर हम सिर्फ यहाँ पे हम एग्जाम्पल नंबर 2 हम लेते हैं जिसमें हम इस फेज रिस्पांस को मैग्नीट्यूड रिस्पांस ये लेते हैं, फेज रिस्पांस को हम क्या करेंगे, हम नॉन लीनियर करेंगे। एंड नॉन लीनियर करने की वजह से हम देखते हैं कि एक्चुअली होता क्या है उस नॉन लीनियर होने की वजह से। So let's solve take example number 2 here. Example 2, फिर हम आपकी बुक में जो उसने एग्जांपल सॉल्व की हुई है ओपन आइम ने इसको बड़ा कॉम्प्लेक्स करके एक्सप्लेन किया हुआ है। इफ यू डायरेक्टली ट्राई टू अंडरस्टैंड द बुक यू मे नॉट बी एबल टू ग्रैब द कांसेप्ट बिकॉज उसने फिल्टरिंग और इसको मिक्स अप कर दिया है जो कि जरूरत नहीं थी यहाँ पे। अब हम ले लेते हैं सेम सिग्नल लेते हैं। So let me redraw the signal again in time domain. So let's take 3 frequencies. This is high. Zoom kar lein, this is very high frequency. So again it's running from 0 to 50. Right? So it's from 0 to 50. This is 0. So let's assume this is x of n. वैसे ये x of t प्लॉट हुआ हुआ है, कंफ्यूज नहीं होना बिकॉज ये कंटिन्यूस टाइम है। तो दिस इज x of t, हम अज्यूम करें कि सैंपल हुआ हुआ है, तो सैंपल अगर होगा तो यहाँ पे सैंपल रह जाएंगे, ये आपके पास कंटिन्यूस सिग्नल डिक्रीज हो जाएगा। ठीक है, लेकिन समझाने के लिए ये मैं 3 डिफरेंट फ्रिक्वेंसीज की साइनोसाइडल बना रहा हूँ। फिर हमारे पास लो सिग्नल स्टार्ट हो जाता है and it's cover only few cycles and it reaches 100 cycles. And then we have a medium frequency that runs from 100 to 150, right? So अभी अगर हम इसका discrete time Fourier transform plot करेंगे, so definitely we will get 3 peaks. This is omega, this is x v2 squared j omega mod. So we will have 3 component. सबसे ऑफर में हाई आएगा, दिस इज 3 किलो हर्ट्ज। फिर उसके बाद रेड आएगा, दिस इज 2 किलो हर्ट्ज। और फिर ऑफर में लास्ट सबसे पहले आपका ग्रीन ब्लू आएगा, दिस इज 1 किलो हर्ट्ज। So 1 किलो हर्ट्ज, 2 किलो हर्ट्ज, and lastly we have 3 किलो हर्ट्ज। Right, so this is x of n. We consider another, we are passing it through a system h of n. This is system. We were passing our input into this system, but now we need to first draw 3 plots of this system. So let's draw the magnitude plot. We draw the phase plot, and thirdly we draw the group delay plot. So this is omega, omega, omega. This is h because this is h, so we are using the h e to raise for j omega mod, and then angle of h e to raise for j omega, you can call it equal to theta of omega, and this is g d of omega, right? So Now we are considering that our system have a constant magnitude response जिस तरह हमने पहले assume किया था. So let's assume this is 1. So it is allowing all frequencies 1 kilohertz, 2, 3 to pass the system without any filtering. Let's consider that the phase response now of a system with we did a mistake. Uh, let me just deconnect and reconnect if I have a right. So let me reconnect. I may get the eraser option here. No, not yet. So what I need to do? चलेंगे अच्छा हो गया यहाँ से हम इसको यूँ कर लेते हैं नीचे कर लेते हैं right? So this is your phase response and let's assume its phase response is like this. हम इसको कट कर लेते हैं और हमारे पास जो phase response आ रहा है let's assume कि it's not real, it's some sort of this one. नज़र आ रहा है it is non-linear. And let me backspace. Now we are in a position to draw group delay and let's assume we draw group delay considering the fact that our group delay response would be like this. So let me take this color. So we assume that 1 kilohertz frequency, this blue one is 1 kilohertz, so हम इसको इधर ही रहने देते हैं. तो हम इसका जो group delay value है वो हम 0 रखते हैं. So since our 1 kilohertz still here, तो हमने यहाँ तक इसका क्या रखा 0. And let's 2 kilohertz is this frequency, it's starting at 100. So let's give a delay, हम इसको delay दे देते हैं 20 का. So it would start from let हम यहाँ से राइज करते हैं ताकि 2 किलोहर्ट्ज में लेट्स अज्यूम दिस इज 20 और जो हमारे पास हाई फ्रीक्वेंसी आ रही है दिस इज 3 किलोहर्ट्ज वी आर इंक्रीजिंग फ्रीक्वेंसी लाइक दिस तो हम हाई फ्रीक्वेंसीज को दे देते हैं फॉर एग्जांपल 0 से स्टार्ट हो रहे हैं तो हम इसको जंबल अप करना चाह रहे हैं तो अगर हम इसको 0 से लेट्स अज्यूम वी ट्राई टू मेक इट 80 हम अज्यूम करते हैं कि इसका ग्रुप डिले जो रिस्पांस आ रहा है वो 80 आ रहा है. So how you read this? You need to. This is your 1 kilohertz, 2 kilohertz, 3 kilohertz. So you just need to look down that 1 kilohertz. This frequency has a group delay of 0. 2 kilohertz has a group delay of 20, and 3 kilohertz has a group delay of 80. This is how we read this. So let me write this as group delay of 1 kilohertz is equal to 0. Group delay of second frequency 2 kilohertz is 20 and group delay of 3 kilohertz is 80. एग्री बेटा इस बात से एग्री करते हैं
Yes, sir.
आप इससे क्या
Yes,
होगा कि
sir.
जो आपकी जो लो फ्रीक्वेंसी है वो अपनी जगह पे रहेगी जो आपके पास 1-2 किलोहर्ट्ज की फ्रीक्वेंसी है वो 20 सैंपल आगे चली जानी चाहिए और जो 3 किलोहर्ट्ज की फ्रीक्वेंसी है उसको 80 सैंपल आगे चला जाना. अब हम इस ग्रुप डिले के बेस के ऊपर सिग्नल को ड्रॉ करते हैं ठीक है तो लेट मी ट्राई टू कम हियर इसको मैं यहाँ से डिलीट कर देता हूँ मैं यहाँ ही पे ड्रॉ करता हूँ ताकि कंफ्यूजन मिनिमल रहे. Now I am trying to draw the output response. So where your low frequency comes, it starts at 50 Let's consider this is a 50 part, 50 to 100, because आपकी लो फ्रिक्वेंसी 50 से 100 तक ही वेरिएट करेगी, राइट. सो दिस इज लो फ्रिक्वेंसी बिकॉज इस 1 किलो हर्ट्ज का जो ग्रुप डिले है 0 है, तो इसकी जो पोजीशन थी ओरिजिनल सिग्नल में वो ही रहेगी. तो ओरिजिनल सिग्नल को देखें तो इट्स स्टार्टिंग एट 50 एंड मूव टू 100. This is red one is the 2 kilohertz frequency. It's starting at 100. Now its group delay is 20. So it would start from 120 to 170. So अब आप देखें आपकी जो medium frequency है that would start from 120 and it will run till 170. What about your highest frequency GD 80 का इसमें गैप आ रहा है, तो ये स्टार्ट कहाँ से हो रहा था, 0 से. तो it would start from 80 and go to 130. So your low signal, highest frequency signal would start from 80. So let's consider this is 80. So it will start from 80 and it will go till 130. Okay, so let's assume this is your 130 point. So this is your output y of n, and this is as distorted output. तो कॉन्सेप्ट क्लियर हुआ. अब देखें इसमें दो इश्यूज आ रहे हैं. एक तो यह है कि फ्रिक्वेंसीज आपकी जंबल अप हो रही हैं, एक ये प्रॉब्लम आ रहा है. देखिए आपकी जो ग्रीन वाला सिग्नल है ये रेड में भी ओवरलैप कर रहा है और ये ब्लू में भी ओवरलैप कर रहा है. तो इट्स ओवरलैपिंग टू अदर फ्रिक्वेंसीज, प्लस ऑर्डर ऑफ फ्रिक्वेंसीज चेंज हो गया. पहले हमारे पास क्या था, हाई फ्रिक्वेंसी आ रही थी, लो फ्रिक्वेंसी आ रही थी, मीडियम फ्रिक्वेंसी आ रही थी. पहले ग्रीन आ रहा था, फिर ब्लू आ रहा था, फिर आखिर में रेड आ रहा था. अभी क्या हो गया कि ब्लू आपके पास सिग्नल पहले आ गया, ग्रीन आपका सेकंड पे आ गया और रेड आपका थर्ड में आ गया. लेकिन ग्रीन वाला जो है ये 1 और 3 के साथ ओवरलैप करता है. So your integrity of frequencies now is not preserved, its integrity gets changed, and your output would be a distorted signal. Any confusion with this, with respect to this concept?
No.
So this is the
No, sir.
This will happen when the phase response of a system is nonlinear. Although your magnitude response is flat, it's allowing all frequency to pass, but it's happening because your phase response is non-linear. Okay, so I left example 5.1 on you. Hopefully you need to read that example. If there is some issue, we'll discuss it next time. So that's all about today's lecture. If you have any question, you can ask.
No, sir, clear.
Sir.
Okay, let me write one last sentence.
सच ये
here.
बुक ओपन नहीं होती लैपटॉप में, कर करके थक गया, एरर आता.
तो बेटा आप डाउनलोड कर लें ये.
डाउनलोड की है
सर हो रही ओपन, बुक ओपन हो रही.
बेटा या आपके कोई वायरस वगैरह होगा लैपटॉप पे.
तो जी ये सारे मसले मेरे लैपटॉप के साथ नहीं हो रहे हैं.
बेटा आप चेक कराएं. But it's opening at my laptop and it's opening on the other student laptop. It's mean that there is some issue with your
Okay,
laptop.
sir.
I think
ओके सर.
maybe the issue with your PDF. So let me remark about phase distortion. When phase distortion occurs, it will disturb the order of frequencies plus the frequencies may overlap with each other. So, this is the phase distortion. When phase distortion occurs, it will disturb the order of frequencies plus the frequencies may overlap with each other. also. Okay, so this is the remarks about phase distortion. Group delay is a very important concept, and phase distortion is again a very important concept. Whenever you go for job interview, especially the company who is working on signal processing, they will definitely ask you this question: that what is a group delay and how you define it. So you should be vigilant to define that group delay is a measure of the phase distortion of a system, and it is a negative of the derivative of the phase response of a system. So they might ask question why you need to take the group delay if you have phase response. So you can say that phase response is linear. So it is slightly difficult to differentiate the non-distortion and distorted concept. But with group delay you can define it very easily. that अगर आपका group delay constant नहीं आ रहा तो आपके system के अंदर phase distortion आ रही है. अगर आपका group delay constant आ रहा है so it means that there is no phase distortion in your system. So with this I am concluding today's lecture. Let me stop the recording. If you have any question